Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So we were actually at perimeters, area and volume. We have already done perimeter and area, and now it's turn to find the volume. And its related thing is total surface area or TSA, or you can also call it lateral area. So let us proceed now. The upcoming exercise is 7.5, but I don't think that we are going to do that 7.5 exercise for two reasons. Number one. Number one reason is that it is a practical exercise and we need not to do it. And number two, that if I skip 7.5, in 7.6 we can cover 7.5 as well. Now, let me tell you that when I was in grade 4 or 5, in our course book, there was a book of arts and crafts in which a hard paper, cardboard like paper was there in, and a figure was drawn. It was an activity. In fact, it was an activity book, and in that activity book, suppose this was the page which was detachable from here. You just tear it up and make whatsoever the activity was there. Now, for example, this was the activity, and here you can see one, two, three, make it like this, and four faces. You see, there are four faces: one, two, three, four, five, six. This is not to scale, in fact. So you may watch it a little different than what I am explaining is. Now, let me do it a little more precise. If I rub it from here, then it will look like something. What I am telling you is now it is a little precise, not very precise, but a little precise. Now you can see four squares over here. One, two, three, four. Two squares on the top and on the bottom. Now this very figure, if drawn on paper, and maybe on this hard paper, you can cut it. You can cut it from here to 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 here and back to its initial position. But in our times, there was also some flaps over here, so it can be glued. Here, and where it is needed. So you can turn this page like this from the dotted lines, all from the dotted lines, from here to here, from here to here, and this is again dotted line. Yes, this is again dotted line, and you can fold this page in this direction and this in this direction, and in the end, what will you get is a cube. Now, my dear students, let me make the cube out of it. So this is a cube. Now this very figure is called isometric cube. Now there are three faces which you can look and three faces which are behind these three faces. If I make it with the dotted line, because these are not visible to you and not to me either. So these are six faces which were made from this artboard or cardboard. Okay. So there are six figures, Faces 1, 2, 3, 4, 5, 6. Now this is called, what is this called? This is called nets of solids. This is called nets of solids. Now these nets of solids can be folded to form a three-dimensional figure. So far so, it is on single plane. Now this is called a single plane because we cannot draw three dimensions on this, but we can assume. Yes, we can assume. See, how can I do it? Now these are the two axes, which are x and x dash, y and y dash. Now you can draw. See this. These are all x-axis. These are all x-axis. This is all axis. This is x-axis, and these are all y-axis. These are all y-axis. There is no other axis on the single plane. There is no other axis on the single plane. But I can draw a third axis which is called a z-axis or z-axis. And all the three axes are 90 degree at the right angle to each other. If you just see it very carefully, you can see that you can imagine that this plane is like this now. This plane is like this now. So you can imagine that this and this are also making 90 degree angle, and this are also making 90 degree angle. The previous one were already made the angle 90 degree like this. Now you can see that this is z-axis, this is x-axis, and this is y-axis. Okay, all the three axes are visible to you here. Now this is x, y, z axis are visible to you here. We can draw pictures, three-dimensional pictures on the board, but we cannot make it like this, because you see, if I open this, now this is a cube, this was cube, this is called cuboid. When there are squares, all the faces are square, then we call it cube, just like your dice. The dice has 6 faces. You just imagine that this is a dice, 1, 2, 3, and 4, and 5. 1, 2, 3, 4, 5, and 6. I think you like 6 the most. Now these all are square. These all faces are square in the dice. You must have played with the dice, and we will be playing with the dice in our next chapter. Dice. Now these are all square figures. Square. Okay, but these are rectangles. See, these are rectangles. 3 types of rectangles are there. Now, number 1 rectangle. Let me make it. Now, this is a rectangle. Okay, this is another rectangle. This smaller one and the smallest one. Now, these are 3 rectangles. Now, this figure cannot be drawn on the single plane like this, because you cannot come out of the plane. You cannot come out of the plane. The third axis is like this. The third axis is like this to it. This is the third axis, in fact. And you cannot draw outside the board. Of course, you cannot draw outside the board. So, this is cube, this is cuboid. This is cuboid. And we will be learning prisms also. This is a right angled prism like this. You see, this is a prism. Now this prism has 6 1 2 3 and 4 5 faces. This has 5 faces. Now 1 2 1 and Behind here is another two faces. You see, I just erase these, you will find all the faces. Now you see, this is one's rectangular figure, this is another rectangular, and this is another rectangular. Two right angle triangles are also there. So there are five. I since I have drawn it on the plane, uh, on the single plane, but I cannot bring it like this outside the plane. I cannot bring it outside the plane. So this was my point, and this was my objective. Now let me introduce to you what are the volume and what are the total surface area or lateral area in these. Now you see, my dear students, that when it has become three-dimensional figure, it has come three-dimensional figure. We are dealing with the length, we are dealing with the breadth, and we are dealing with the height. H-I-G-H-T, height. H. Now this is height. Okay, we are dealing with three dimensions: height, breadth, and depth. Now you see, since this is a cuboid, this is a cube. Sorry, this is a cube. In cube, all the three dimensions are equal. All the three dimensions are equal. We can say it as, we can say it as, we can say it as, because these are equal. Since this is S, this is S, and this is S. You see, this is height, this is breadth, and this is length. But in the case which I told you, you see, if I put it like this, if I put it like this, you will see it three dimension. Or you can look in your room, the corner where your roof, where your one wall and where your other wall are coinciding. In the corner of the roof. Okay, now this is, you see, this is length, this is height, and this is breadth. Okay, this is length, this is breadth, this is height. Okay, now three dimensions. And for area, and for area, and for area, yes, you know, area was length into breadth. What was the area? Length into breadth. And for the volume, it is simple that you multiply it with the third dimension available to you. Okay, my dear students, the third dimension available to you is now the height of the object, the height of the object. Now we'll transform this formula in where we are required like this and like this, and even to the cylinders also. Now there are two. If I have a cylinder, yes, I have a cylinder in my hand. Now this is a cylinder. You see that here on the top it is one circle, on the bottom it is one circle, and this is the length. If I open this, it will be like this. Okay, I have opened this marker. Now it has become like this, the top circle and the bottom circle. Now what will happen here? It will happen that the area of, now we'll be doing the area of cross section. Now this is the area of cross section, cross section multiplied by length. Now this is the length. Here, from here it is length, and area of cross section is of course area of circle. Now area of circle multiplied by area, length, will be the area of this volume of this marker. Okay, this cylinder. Okay, now let us start from the exercise 7.6. Now maybe we'll be doing it very quickly. Yes, now this is I have reached to exercise 7.6. Now we'll be learning whenever the new things come, we'll be learning it right from that beginning. Now, my dear students, exercise 7.6. I have already told you that we'll cover exercise 7.5 because concepts are the same. Since the concepts are same, so we need not to do the practical side of these questions. Uh, as far as your examination questions are concerned, you are not going to do the practicals in that, mathematical practicals. Exercise 7.6. Now, in exercise 7.6, a figure is given to you. Question number 1. Now, this is a figure given to you. Question number 1 and part is, this is only question number 1. There are no other parts. Okay, and some triangles sort of thing is also given to you. Okay, now this is given. My one student has asked me that I am getting some different answers whenever I calculate. Now there is one reason for getting the different answers, that you are following the keys. The keys are commercially prepared. They don't care either you know the concept or you don't. You understand the concept or you don't. They just keep on writing, keep on writing and solving the questions, and you cannot even understand their concepts. Okay. Now, if you follow my lecture, you will be able to understand the concepts very well. Now, this is given. You see that this is 3 centimeter. All that dimensions are in centimeters. Okay. Now, this is 4. This is, I think, 5. Yes, this is 5, and this is, there is also one more thing given. Yes, 11. All the dimensions are given in centimeter. 11 centimeter, 5 centimeter, 4 centimeter, 3 centimeter. Okay, now my dear students, you see that this is 5 and this is also 5. Because this part, when we fold it, will be joining this part. Okay, and this part will be joining this part. This part, this 3 centimeter part will be joining this one part. Okay. Okay, so this is 3, and this is 3. This is 11, this is 11, and this is 8. So this is the whole story over here. So what we have to find is, we have to find the volume and surface area. We have to find the volume and total surface area. Now, in your book, it is written SA, surface area, but in fact, it is total surface area. It is total surface area. So, it is very easy. Just forget these two triangles. Forget these two triangles. Okay, my dear students, just forget these two triangles. I just hidden the triangles. You see, I have hidden the triangles. Now, what is left with you? There are 3 rectangles you are seeing. Okay, now again, these are already hidden. These are, just imagine that these are hidden. This triangle is hidden. This triangle is hidden. Now, also hide these 2 lines. Also hide these 2 lines. Now, this whole thing is hidden. This whole thing is hidden. These 2 lines and these triangles are hidden. Only what you are left with is, this rectangle. Okay. Now, this rectangle is 11 on one side, 11 on one side, and 5, 5, 4, 9, 9, 3, 12 on one side. It is, length is equal to 12 and breadth is equal to 11. How the length is 12? Just add 5, 4, 9, 9 and 3, 12. Breadth is 11, which is already given to you. So just multiply for the area. For the area, just multiply it. It will become, now my dear students, it will become 132. 132 centimeters square, because this is area of this rectangular figure. Area of this rectangular figure 3, 4, 5. Add this 12 and 11. Now this is the area of this rectangular figure, but it is not finished yet, because we have to find the total surface area. Total surface area. Now just just assume that this just assume that this rectangular figure is gone. You hide this. Only you have two triangles left. So one triangle, the area of triangle is half base into height. And the area of two triangles, similar triangles. These are similar triangles. See, the straight line, this is also given. Yes, this is also given over here. Now this is the straight line, this is the straight line, 3, 3. This is the hypotenuse 5, hypotenuse 5. So these are identical. So it is, if I make it like this, understand what I did? Understand what I did? I just make it one instead of, you see that how I made it. There are two triangles. There are two triangles. Area of triangle is equal to two triangles. Now there are two triangles. Area of two triangles is 2. Now this goes with this. This is what I did. So base is 4 and height is 3 given. Yes, this 3. Now it will become 12 centimeters square. Centimeters square. Now this is your second answer. One answer was this and the second answer is this. The area of two triangles. Now the area of one triangle will be 6. Remember, area of one triangle will be 6 and the two triangles will be 12. Now add 132 with 12, you will be getting 144 centimeters square. 144 centimeters square. Now this is the total surface area. It is the total surface area. Okay. Total surface area is equal to 144 centimeters square. Let me check it out, because of the student which was complaining that the answers are not correct sometimes. Now let me check. In case I cannot take the surety of the keys there. Yes, it is 144. Okay, it is correct. 144 centimeters square is correct answer. It is correct answer. Now what about the volume? Now if you just see, if I fold these to make a prism, if I fold this, I'll fold this and join this 5 with this 5, this 5, this 5, this 3 with this 3, this 3 with this 3, and eventually 11 will be meeting this 11. So it will become like a figure like this. A figure like this, and it will be like this. Now figure will be like this. Now this is again 11. Okay, this right side is 3, the base was 4, hypotenuse was 5. Okay, all the dimensions have been covered in this prism. This is a right angled triangular prism. Right angled triangular prism. Okay, now let me calculate. Now this is formed. Okay, now this right angled triangular prism. Now what we do for the volume? For the volume, I told you. Now for the volume, we'll be doing that. We'll be taking the perimeter. What is the perimeter of this? This is 7 and 5, 12. And okay, the cross section area will be for volume. For volume, we'll be taking the cross section area. The cross section area multiplied by length. Multiplied by length. The cross section area is equal to half base into height. Half base into height we already done here, which was 6 in fact for one triangle. For one triangle, it was 12 for two triangles. Okay, 6 into length is 11. It will become 66 centimeter cube because there are three dimensions now: one dimension, second dimension, and third dimension. So there are three dimensions. So it is come 66 centimeter cube. Now let me check it again. For each question, I have to check it because okay now. Understood that this is 66 centimeter cube. So my dear student, question number 2. Now there are some data is given in question number 2. I am going to do first only part A. Just do part A and part B is same. L means length. Length is given 5 centimeter. B is 8 centimeter and height is 18 centimeter. Now this is, it is also written that this is cuboid. This is cuboid, and I have already shown you what is cuboid. Now this is cuboid. Okay, so this is cuboid. So what we do here is, for the cuboid, how we take the total surface area. We take the total surface area, or surface area, is equal to 2 multiplied by, now this is 2 multiplied by A, B, B, C, and C, A. Now what are A, B, B, C, and C, A? Let me draw this cuboid. Now you see, this is a cuboid, and see how I drawn it. This is at the angle of 30 degree. This is rough. Okay, for isometric you take it 30 degree. Okay, now length is 5 centimeter, breadth is 8 centimeter, and let me change because this is a longer one. This is 8, this is 5, and height is 18. Okay, 18 will come over here somewhere, but just imagine that this is right. Okay, not to scale, for easy not to scale. Now just mark that this is A, this is B, and this is C, or you can take at your own will. Okay, now 2 multiplied by A into B. A, B. A into B is, now this is A, this is B, this is C. Okay, just forget these. I am taking from the near spot. AB. AB is 5 multiplied by 8 plus BC is 8 multiplied 18, and CA is 18 multiplied by 5. Okay, just calculate this. 240, 8 5 times that is equal to 40, 8 18 times 144 plus 8 times 5, 18 times 5, 90. Okay, it is 90. Now just add these because these are in bracket. Answer is equal to 40 plus 144 plus 90. This is 274 multiplied by 2. It will be equal to 548. 548. Now this is the, since surface area, it will becomes in uh, centimeter square. Okay, answer is correct. Now what about the volume? What about the volume? I've just told you volume is simple, is very simple. That is area multiplied by height. What is area? Length into breadth. multiplied by height. That means you have to multiply all the three dimensions given to you. All the three dimensions, you have to multiply all the three dimensions given to you. But since, okay, area multiplied by height. Now, all the three dimensions are 5 multiplied by 8 and multiplied by 18. Multiplied. Now, this is in centimeter, this is in centimeter, this is in centimeter. The answer will come in cube. The answer will become in cube. 18 multiplied 8 multiplied 5. It is equal to 720 centimeter cube. Centimeter cube. Okay, not scare, because there are three dimensions: centimeter, centimeter, centimeter. All the three centimeters will also be multiplied to get centimeter cube. So this is again the answer is correct again. There is no discrepancy in the answers so far. Now, what about question number 3? Let me take question number 3 now. In question number 3, it is very easy. A battery, a UPS battery is given to you. You can see at page 152 of your book. Now, again, it is a cuboid. It is again a cuboid. So, I think it need not to be done again and again, because the question I just erased is just same. The dimensions are different, but it is the same. Question number 4 now. Question number 4. Question number 4 is again the yes, I did it just now, but for your sake I am going to do it again. 32 centimeter, 6 centimeter, 8 centimeter, and the hypotenuse is 10 centimeter. Now, my dear students, this question is the same question which I did in the start of the lecture. You just imagine that there are three rectangles in this figure. Three rectangles in this figure. Now, these which I am going to make in dotted is hidden, is at the back side of this figure. Is at the back side of this figure. Now, there is a rectangle. Rectangular number A, RA, is 6 multiplied 32. Rectangle number 2 is B, which is RB. Rectangle RB is 10 multiplied 32. And rectangular C is 8 multiplied 32. The length of each is same, but the widths are different, breadths are different. So it is 8 multiplied 32. Now there are three rectangles. Okay, now we'll find the area of each rectangle. Now it will become 182, it will become 320, it will become 8 2 times 16, 8 3 times, it will become like this. Okay, just add these if you have to find the total surface area, TSA. You have to find TSA, total surface area, lateral area. Now, area of one rectangle, second rectangle, and third rectangle. Only one rectangle is visible to you. The two other are behind the scene. So, area is the total area of three rectangles. Of each rectangle is given in this, and for three, the consolidated is 182 plus 320 plus 256 will give us 758. 758 and plus two triangles. Now, since these triangles are same, so I am going to take half base into height. It is equal to, now this is base 6, half base is 6, height is 8. Now cancel this. It is 24, and 24, when it is 24, for 48 for two triangles. 48 for two triangles. Now since we have two triangles, this is the area of one triangle, this is the area of two triangles. Just add this. It will become 6, it will become 5 and 5, 10, 806. So it is 192, not 192. It is 192, this is 320, this is, at first I written it 182, it was wrong. So it will become 8 and 768 centimeter square is the 768 centimeter square is the answer for the three rectangles RA, RB, RC. Now add this 48, it will become 6 and 1 and 8, 816 centimeter square. It will remain centimeter square over here. 816 centimeter square is the total surface area. And we have to find the volume as well. Yes, we have to find the volume as well. Now volume is again very easy. We'll find the cross section area. Cross section area is equal to half base into height. Half base into height multiplied by the length. This is the volume of this right angled prism. Triangular prism. It is equal to half base. Base was 6, I think. 6 centimeters. Yes, it is 6 centimeters. Base is 6 centimeters. Height is 8. Into length is 32. Okay, just cancel this with the most bigger value. So it will become 48. 48 multiplied 16. 48 multiplied 16 is equal to 768 centimeter cube. Okay, now check the answers. Are we correct or we are 816 centimeter square, okay, and 678. Okay, now this is correct, both answers are correct. Now cylindrical, yes, I was looking for this. Question number 5. How many questions we have? Okay, we have some more questions coming up. I am going to finish this exercise today. How much time is we take? I am going to finish. Now, don't go for the whole story. Just take the dimensions of the cylinder. The cylinder is like this. Okay. Now this is 3 centimeter, and this is the diameter is how much? Volume. I am going to take the volume only. It is very easy. We don't have to find the area. Just we have to find the volume. So volume. When you say volume of the cylinder, I just told you. Just we will take the cross section area. Now the cross section area is this. This is called the cross section area. So cross section area of the circle. The area of a circle is pi r square. Now your new volume is your square of the uh, area of circle is equal to 1.1304 meter square. It with now this is the area of this circle. Area of cross section is this, and we are going to multiply it with 3. We are going to multiply because this is length. Shifting of the, or you can also 3.39 or 3.3, 3.4, you can say it 3.4 meters. Sixth part is same. Seventh part. Sixth part is same. With just 2.2 given over here and 10 given over here. And I'm going to do 7th question now. Question number 7. To finish the exercise, we have only 2 questions left. Now there is this sort of figure is given to you. Just make it very quickly. Okay, now this is a cuboid, diagonal solid glass case. Now this is a solid glass case, and in this solid there is a hole of cylinder like this. Okay, this is a hole over here. What we have to do is the diagram shows the case of cuboid removed to fit the clock mechanism. Calculate the volume of glass required to make the clock case. Volume. Now we have to. Okay, now this is very easy, my dear students. Don't be afraid that what has given to you 10, 8, 10, 8, and the diameter is also given, it is 5. And the length is again, length is, because this is 4 cent, so 4 centimeter. Okay. Now simple, that we have to find the volume of this, we have to find the volume of this cuboid excluding the volume of this cylinder, volume of this cylindrical hole from here to here. This is a hole done in this glass slab. Glass slab, you know, glass slab you might have seen in physics lab. Glass slab. This is a glass slab, and there is a hole in this glass slab. There is a hole in this glass slab whose diameter is 5 centimeter and length is, it is through, since it is through, its depth is 40 all 4. Okay. No, I don't. I'm not concerned with what they are going to make. I'm just find the area of this cuboid now. Now I'll first find the area of. I'll find the area of cylinder. I'll find the area of cylinder. Okay. Now the cylinder of area, the area of cylinder is pi r square. Pi r square multiplied by 4, because it is through from here to here. It is through from here to here multiplied by 4. Okay. Now this is the volume of the hole. Volume of the hole. Volume of the hole is this. Now this is 3.14 multiplied by, this is 5, so it will become 2.5. 2.5 the whole square multiplied by 4. Okay, now this is the whole story of this cylinder. Yes. Now this will become 6.25. Rest of the things are same. Okay, rest of the things are same. The volume of this hole in is 78.5 centimeter cube. 78.5 centimeter cube. And of course, we have to find the volume of this. Okay. Now there are three dimensions also given for this. For this, volume of cuboid. Cuboid. Volume of cuboid is equal to 10 multiplied 4 multiplied by 8. It is 32 and 320 centimeter cube. Okay, 300 and you just multiply 32. 32 multiplied 10 is 320, and just subtract the area, the volume 78.5 from this. 78.5 minus 320 will give us, it will become 241.5 centimeter cube. 241.5 centimeter cube. Again, check the answer. Okay, it is okay. It is correct. A storage company has rectangular storage area of this. Find the volume of storage area, format cardboard, the dimension can fit the storage area. What is the surface area of each cardboard? Okay, this is a very interesting question. I think we are very beyond our time, stipulated time. Oh, yes, we are very beyond. But I am going to finish this exercise today. How I don't, it don't matter that how much time we take. Now, question number 8. Question number 8 is, a storage company has a rectangular storage area long. Now L is equal to 20 meters. It is given in word problem. 20 meters wide. Wide means breadth, it is equal to 8 meters. And height is equal to how much? 2.5 meters. Now this is the storage area. Okay. Now what is behind? Find the volume of the storage area. Just multiply all the three dimensions. Volume. We have to find the volume. Now volume of the storage area is equal to 160 multiplied by 2 is 320 448 meters cube is the 448 meter cube is the storage area in this uh, the part A. Now this is the answer for part A. The next, how many cardboard boxes dimension? Now the boxes have to be fitted in this 1 meter, this meter fit in the area. Now part B. Now these are the now these sort of boxes have to be fit in this, or you can say that this sort of boxes have to be fit in this storage area. Now what is given in this? 1 meter, 0.5 meter, and okay. Now this is 1 meter, and this is 0.5 meter, and this is how much? This is 2.5 meters. Okay. Now get the volume. Get the volume of this one box. This is the volume of one box. Now volume of one box is equal to zero point 0.5 multiplied by 1 multiplied by 2.5. This zero point 0.5 will make this 2.5 half. It will become 1.25 meters cube. Okay, let me calculate it on the calculator. 0.5 multiplied by 2.5. 2.5 is equal to this, Yes, it is 1.25 meters cube. 1.25 meters cube. Now, we'll divide, because this is the storage area, this is the volume of one box. We'll divide this with this. 448. Now, the uh, quantity of boxes of volume 1.5 1.25 meters cube is equal to volume of store divided by box volume of box, that is equal to the quantity cube. It is equal to 448 meters cube divided by 1.25 meter cube. Now this will cancel this, because this is quantity and quantity is in numbers. 448 divided by 1.25 is equal to this, and that will become 358.4. Now you cannot store 0.4, so the answer will be 358. 358 numbers of boxes. 358 boxes. Because you cannot store a half box. Okay, so you have to neglect this, and for easy sake, it will be 350. Your answer is correct. Okay. What is the surface area of each cardboard? Now, the surface area of each cardboard. Now, this is the cardboard, and we have to find the surface area. So, area of each box, whatsoever was the cardboard or whatsoever it was. So, there are one triangle, one rectangle. Now, surface area of cuboid, I told you already about it. Just assign the names to it: A, B, and C. This is A, this is B, this is C. It will become 2 into AB plus BC plus CA. Okay. Now all the dimensions will be multiplied with each other, and then with the aggregate will be formed. Now AB is this. AB is 0.5 multiplied by 2.5 plus B is 2.5 again multiplied by C is 1, and again C is 1 and multiplied by zero point 0.5. Okay, now it will become 2 multiplied by, now this will become 1.25, this will become 2.5, and this will become zero point 0.5. Okay, all the dimensions have been calculated. So just add these all the dimensions. It will be 8 point. It will come 8.5 meters, centimeter per meter. What was it? Meter square. Okay, it is correct. Now next question is almost like same. So it's time to see you. It's time to say you goodbye, and it's also time to sign off now. Signed off. So if you find any difficult, you can ask me in the comment section below. Don't be shy or don't be afraid of calling me, or don't be just hesitate. Don't just hesitate to ask me. I'll be always be there. Okay, it's time to say you goodbye. Allah Hafiz.